Like, yeah. So this is basically the same thing that we did last night, just one fewer step.
Awesome. So where should we start?
Sum of squares.
So in your second column, are you squaring them already?
Yeah, these are the squares. Yeah.
Awesome. It's kind of distracting with the numbers there.
Yeah, so that's when I first saw this, I was like, are those part of this? But that looks like all full up.
Yeah.
Okay. 16, 27, 32, 38, 15, 23, 27, 31, 36, 4, 11, 16, 32, 48 squared is 2304, 36 squared is 1296, 32 squared is 1024.
Good job.
That's this part. 36 squared is that part. Squares that part. And then there's 1, 2, 3, 4, 5, 6. Okay, nice pencil. 6.
For this one, I think you need to redo your math. For this section.
For this?
Yeah.
33 squared is 1089.
Well, not for that.
Oh.
For just to get the 32.
4, 11, 16. Oh, it's 24. Yeah. You're right. It's 576 though.
Good job.
Okay. And then of course you gotta add all that up. 136, 161, it's 282. 18, that's 363. 37, that's 412.
No, I did the wrong number. I see it. You're right.
Okay. 4157.
Well, hold on. 136, 25, huh? Not 23.
That's 25, yeah.
Yep, you're right.
You've done that a few times.
I know, I always do that. I'm sorry.
No, it's fine. It's like my... So it's 189, that's 205, 221, 246.
Yep. Good job.
74, 90, 106, 114. Yeah, it should be 114.
Yep.
Okay. So then...
And then what is the equation that you're using right now?
Sum of squares. Okay, well, I think I'm at my limit for that. I haven't figured out division yet. My noggin. Divided by 6 equals 16. 246 minus 216. don't know if I've ever had a calculator this worn down.
I know. It's pretty old.
It just
Last
means
me a
you've
minute.
used it.
Yeah.
Okay. 74.
For what?
I know you're supposed to add the sum of squares.
For which part?
Is that the between groups? Or is it the within groups?
What do you think?
Trying to remember what we did.
Do you have it in your notes?
Yeah, I have it in my notes, but I want to kind of... If I can figure it out without having to look at notes, then that means I can at least do it on the
You can,
test.
yeah, you'll remember how to do it.
So... what did we do today? I got this out on homework. Do you have homework? Yeah, I need to write better notes.
I have the formula sheet if you want to look at it.
Okay. Some squares total?
What did we do last time for sum of squares total? We kind of forgot about how there was any levels, right?
Yeah.
We just said it was all one thing. So would that apply to this one?
Yeah, that's not the total. Yeah, it'd be the total sum of squares, wouldn't it? No?
No. So what are we doing here? Can you explain to me what we did?
We found the sum of squares for, we're trying to fill out this column right here.
Mm-hmm. And so we found the sum of squares for each treatment, right? So for the 0 seconds, 0.5, and the 1 second.
Okay.
So what formula on here would be the sum of squares?
I mean, I think it's between groups. Sum of squares total minus sum of squares within groups.
So how do we find within groups?
Yeah, see, this is just terminology.
So if we're doing sum of squares total minus sum of squares within groups,
Yeah.
how do we get the within groups?
Yeah, I don't know.
What does this mean? This little symbol.
Sum of squares.
In each treatment, right?
Yeah.
What do we do here?
The sum of squares.
In each treatment?
Yeah.
Yeah, so
okay.
we found the within groups, yep.
Okay. Now the between groups.
So do you want to do the between groups or the total?
Well, I mean, if you have the between groups and the within groups, you can use that to find the total.
Mm-hmm.
Or you could also use the total.
To get the within groups?
Yeah.
Or between groups?
Yeah, I mean,
That's up to you.
I think you can do either. Now the question is, which is easier? How do I do either?
Well, let's look at our equation.
Oh, both seem like a pain in the ass to me, but that's these formulas. I don't know. It's like I'd rather memorize how to do this without having to even look at these things.
Well, yeah, but you have to learn how to do the formulas first, right? To be able to memorize them.
It was like all these other tests that I've done. I've never really bothered looking at the formula sheet because by that point I had already memorized it without having to see all this convoluted terminology and crap. I don't really know.
So earlier when we were talking about how if this wasn't split into levels,
yeah,
how would we find the sum of squares?
You just that, and it'd be just one sum of squares if it wasn't split into levels.
So if like this wasn't here, right?
Yeah.
So what do we do based on this part to find the sum of squares?
So if we were assuming this is all just one thing, you do this for all of it. You just do that, but it'd be just a longer list.
And it would be, you would get different numbers, right?
Yeah, of course.
Mm-hmm. So would you say that's how you'd find a total sum of squares?
Yeah.
Mm-hmm. So you think we should try that?
So do this all again for just one giant? I don't know. Is that what we did here?
Mm-hmm.
On the other? Did we?
Mm-hmm.
I mean, how do we do it that way then if we did it? Is that really what we did?
Mm-hmm.
I don't remember doing it that way. Oh, that's not... Like, are you talking about like adding these up? Is that what?
Well, what's our equation for sum of squares?
I just know how to do it. I don't know how to try out the equation.
I think you can do it. Good job. See, you did it.
Yeah.
So, we do have, what is this? This number that we have here.
That is... That's this.
Mm-hmm. So we have to square that, right?
Yeah.
And then,
And this is 412.
right. So, if we're doing the whole thing though, we're gonna have to put all three groups
Okay,
into
makes,
that, and then square it, right?
80, 20, so 116, square 116.
We didn't. Did you do 24?
It's 24.
Okay.
Never mind. I got
Okay.
should probably erase that. It's 20, 24, 36, it's 60, 108 squared. I can do that in my
Big
head.
number.
Yeah, it's somewhere around 11,800-ish.
Want to try it?
Yeah, I can. Yeah. 11,664. Oh, I see. 64. 8 squared, 64. 8 plus 8 is 16.
My brain does not work like that.
And then since 1, 2, 3, 4, 5, 6, 12, 18.
Mm-hmm.
And then just add this, and then 576, like that.
Hmm?
For this number. Because these are the total of all of this for each. I'm just figuring like
Well, if this is saying the sum of x squared,
okay.
then didn't we get 412 for this one? Because that's the sum of x squared.
Oh yeah. Okay.
So then what did we get for these ones?
Okay. Yeah.
Good job.
Okay. Too lazy to do that. I mean, I can. It's just effort now. $772. That's gonna be a huge number. That's already squared. Never mind. Okay. One, two, four.
What do we do there? What was that?
Total.
Mm-hmm. So then if we have the total and the within groups, how do we find the between groups?
You just
Mm-hmm.
subtract 74 from 124.
Good job.
That's a great number though. 124. Oh,
Is it? Yeah.
Yeah, I think it is. Yeah, never mind.
Good job.
26, 24, 50. Degrees of freedom.
Perfect. So what are our equations for degrees of freedom?
One's like k minus n minus k.
There's
And
one
this,
more.
what was that? Eh? No. Is there one more?
Well, these are... I think you got these confused. Let's look at our other equations that we've used. Like, do you have them written down?
Somewhere. Probably. I haven't written down there somewhere. Here? So they just.
So this is one. This
Okay.
isn't one.
So I don't know why I have it then. Is it.
Mm-hmm.
Okay.
And then you have one more.
Really? Okay, it's.
So these are the two that you use when you find your critical value, right?
Yeah.
For your degrees of freedom between groups? What's that? What's
Well,
your equation?
that's the levels minus 1.
1, right?
Or in this case, like if there's 3 levels, it'd be it'd be the level minus 3.
No. Because what does K mean?
That's the levels
Mhm.
of the groups.
So it'd be K minus.
So it'd be 3 minus 1.
Mhm. Yep.
Yeah. So in
And
this
then-
case, it's 2, which would be 25.
And then for your degrees of freedom within groups or your degrees of freedom error, what do you have for your equation?
So this would be 18 minus 3,
Mm-hmm.
which would be 15.
And then what would you do for your total? Mm-hmm. Because this equation here is K or N minus 1, big N minus 1.
Okay. Maybe just a little bit less than 4. 4.93. Yeah.
So then how do you find your F?
25 divided by 4.93. 5.07. Right.
Perfect.
No, it's like, I don't know why this is so much easier than some of the other stuff I've done. It doesn't make any sense.
It's a lot of steps to this one.
Yeah, but they all kind of make sense. I don't know if they really make sense, but I know how to do them. It's not hurting.
That's good. You went through that one pretty fast.
Compute Tukey's HSD post hoc test and interpret the results.
So I just did this one with Lauren.
I don't know if we're actually supposed to do this.
So you usually don't have to. Like
Well,
usually we do it with SPSS.
Yeah, what I think he said is that he's going to be, because remember we got the omega squared from the last homework. He said not to worry about those because he's going to go in and edit them.
Okay.
So instead of you doing omega squared for that one, it's going to be eta squared.
Eta squared, okay. So that'll probably be the same thing for this.
So I mean, we could probably go back to this other one and try and calculate that. I'm not sure when it was. Yeah, eta squared, which I know is.
Okay. So how do we go about finding T?
Yeah, it's the. Yeah, I don't know how to get T with this information that we have.
Well, what's our equation for T? You know?
Is it standard deviation? I know one of them standard deviation, one's standard error of the mean, isn't it?
It's this one. Yeah, because that's a standard error of the mean.
Oh. So we know this sum of squares.
We can basically get all that information, right?
Yeah. We had some. I'm assuming like one of these are some squares that we can use, but I don't know which one. Like,
I'm not sure what we would use for our M's for this.
yeah, no.
So for like the other one, it would be easier because we have the raw data. You know?
Yeah.
But for this one, I'm not sure what we would use for our M's. Oh, so I have a different equation for this one. Have you guys talked about this one? The SS between treatments and SS total?
If we have, I don't remember it.
So I would maybe wait and ask him because I don't want to tell you this. But this is what we used for ANOVA.
Okay.
And then it was just your between groups and your totals.
Should I just divide those?
Mm-hmm.
So 160 divided by 72. Wait. Between groups. So it'll be 72 divided by 0.45. Okay.
There you go.
That makes sense. That's
A little bit easier.
simpler.
Yeah. But with the other one, you could use this formula.
Yeah.
Since we're given them raw data.
I'd rather just not.
Rather not do that.
Yeah, that's.
It takes a lot of work to get to the answer.
Okay. Which of the comparisons had significant results? What is it asking?
So it's saying like between which two was there significant results? Because would our results be significant here?
Well, it's like right next to 5%, right? Like.
Well, do you have your tables for your critical bias?
Not with me.
No.
Not with me, no. Eh? I must have accidentally stole it from class today.
So what do we do? How do we find our critical bias?
Well, I go to 2, column 2. Maybe 50? No, it's 18.
Let's go back and look in your notes. How we found it.
Well, I know that, like.
So if you were to write this in like your APA statement, how does it look? Like it'd be like F.
It'd be F2 number, and this would be this top column, and then this number would be the side column. Degrees of freedom denominator. I didn't want to say 17.
Let's look. I saw it in your notes before when we were looking for the equation.
Oh, that's good. It's written somewhere. This?
This one's not going to really tell you. The other one that I saw would tell you. So, yeah. No.
Yeah, look at that. Got a square right there. And we have talked about it.
Hey, you guys did talk about that. Good job. Oh, I found it. It's right here. It has to do something with right here. And I'll tell you where you get that number from.
Degrees of freedom estimated. So
Error, right?
Error, yeah.
Mhm.
Degrees of freedom error. 15.
Mhm.
I was gonna say 15, but I never got to it.
It's better to look it up than to just guess it. So you're not
Yeah.
gonna remember it.
2 to 15. This is. It's not the alpha value. Doesn't say the alpha value anywhere. I mean, if it doesn't give the alpha value, you just assume it's 0.5 since it's behavioral stats.
Mhm. But it does say down here too. But it says assume alpha value is equal to 0.05.
Yeah, I was kind of ignoring that because we're not supposed to be doing that, but okay. Light phase. So it'll be 3.68.
Mhm. So then how does that look on our curve?
And our number was 5.07, right? Or to be out here.
You tell me. How does that work?
So this is supposed to. Yeah, so this is supposed to add up to like 1, right? Like whatever's here is supposed to add up to 1. Because like the other side is like reciprocal, so. Something like that. I don't know.
What do you mean?
I know we had a question earlier about. Like in one of these, I don't remember what the question was. Was that a quiz? I didn't actually know the answer. But he gives the answer afterwards, I'm trying to think. This is something that has to do with like when you retain the null hypothesis and it's in like a distribution for the F statistic. It's like when does it equal 1 or something, I don't remember. I know every time we do these, like usually it's out here, right stuff.
So what do you think? This is just gonna look like a normal bell curve, like just like what we've been doing. Like these are just points that we can compare to like a different point rather than like a raw score.
Yeah.
So like this is still gonna have your 3.6 or cut off over here, but like let's say if you got a negative one, then it would still be over here.
Okay.
Does that make sense?
Yeah,
Okay.
of course.
So what do we do?
Well, we reject the null for 1.
So we have significant finding, right?
Yeah.
Okay. So what this is asking is which of the comparisons had significant differences? So we're saying, what does like an F distribution tell us?
See, I think we went over that on Friday. I know it has to do with variance, right?
Mm-hmm.
It's like analysis of variance, so it's like determining how much like things vary between the different conditions.
Mm-hmm. Yeah, absolutely. So like when we have our between groups, we're saying is like, so that for this example, it'd be between each the 0 and 0.5.
Yeah.
And then between the 1. But then it's also saying how much variance is in that one group itself, so that's within groups, right?
Yeah. Okay, yeah.
Mm-hmm. And so since we have a significant finding, would you say that there is a significant variance between all 3 of them?
Yeah.
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 So based on that, which one would you select, or which ones would you select?
None of these, like, so it's like we call for half-second delay, falling pass. Well, I mean, you would assume like the answer would be one that includes all 3 of these, right? Well, I would say this one.
Mm-hmm. Why that one?
Because it says no recall as compared to 1 recall, but I'm guessing in that it would also include 0.5.
Mm-hmm. You're absolutely right. Good job.
I don't know why any of this makes any more sense than anything else. It's like sometimes when you ask those questions on the other stuff I used to do, I would be completely clueless. But in this case, I, for some reason, have an idea.
Yeah, that works.
Even though I missed Friday, which doesn't make any sense. Like, I missed a day on this, and I feel like I was 3 weeks behind, and all of a sudden I'm, like, right on top of it.
Sometimes things just click better.
Yeah, let's see what time it is. 12, yeah, we got time. I have class at 1:25.
Okay. Good deal.
Oh, this is a whole lot of just scary. Let's probably one more time.
So what are you filling out now?
This is asking the levels of each factor.
Mm-hmm. So for gender, there's 2.
Yeah.
Mm-hmm.
So for this one, are we just looking at these?
You tell me, what do you think?
I was asking, this is like the alpha values, so...
Mm-hmm.
That's weird. These are P probability.
Mm-hmm. And what does it mean when it's significant? How does that look? What do we write in our AP statements? APA write-ups?
Like when we list out the actual statistics that we found?
Yeah, so if it's a significant finding, how does the P look?
Well, P is like greater than?
For what? Which one?
I don't know.
Significant or not significant?
What's that saying? So the probability is that it's less than 0.5%?
For which one?
For significance.
Mm-hmm. So if the P is greater than 0.05 for this one, is it significant or not significant?
Well, if it's greater than that, not significant.
Not significant.
Yeah.
We'll retain the null, right?
Yeah.
So if it is significant, how does it look?
Like that.
Mm-hmm.
Reject.
Mm-hmm. Mm-hmm. And so if we have our P's, how can we determine if something's significant?
Good question.
So, like, let's say this is an equation.
Yeah.
What do we fill in here based on the information we're given?
It's like, I don't know. Brain died.
So, this is a P, right?
Yeah.
Where else do we see a P with what we're working with?
Probability?
Mm-hmm. So right here, right?
Yeah, of course.
So then, would you say that we can just substitute this number in for this P?
Well, yeah.
And that will tell us if it's significant or not?
That.
Mm-hmm. So is that right or wrong?
I think that's wrong. Because this is like 40.9. This is 5%. If we turn them into percentages.
Mm-hmm.
So this is completely...
So that would be what? So would you reject the null still, or would you retain the null?
Retain?
Mm-hmm. So it's not significant, right?
No. Okay. This is significant then.
Why?
Because this is 2.9%, which is within that 5% that we're looking at.
Yep.
And this, something less than 1%.
Mm-hmm.
So like that would, again, count. And then of course, this would not count.
Okay.
Because this 53.6% is way above 5%.
Yep. I'm silly. Good
Okay.
job. So that makes sense why we did it that way.
Yeah, it does now, yeah. I think I just had to turn it into percentages and then it made more sense.
More sense
to me.
too, yeah.
But I think that's kind of how it is for most people.
Mm-hmm.
I just realized that there's another this over here.
I'm gonna end this.
How long is it supposed to be?
30 minutes.
Oh.
I think it's been 30.
Yeah, it should be.
Well,